Hi, welcome back to the Introduction to Python Programming. This is section review 1. In the previous video, we reviewed sections 2 through 5. In this video, we're going to do sections 6 through 10. So let's go ahead and get started. Section 6, loops. The question 1 is iteration. Iterate through the list and create a new list that contains the words that begin with T and F. Question 2, breaking out. Change the while loop to an infinite loop. Use break to end the loop when the user inputs a cue. So typically you'd want to avoid infinite loops, but in this instance we want you to create one. And then we also want you to use that input function that's being used, that's a standard Python function, to catch user input and make the decision when to break out of that loop. And that's how that loop will end. Question 3, modulus. What prints out? What would print out if the I equal I plus 1 line was removed? That's line 5. From the loop. All right, so go ahead and take a second to see if you can answer those. Pause the video if you need to, because we're going to go over the answers in 3, 2, 1. Here we go. Answers, iteration. So we can see the coded answer there is we go for item in A, and then if item splice 0 to 1, so that's character 1, is not in T and F, which is in a list, an inline list, we continue. So we're right there, we're saying, hey, does this word begin with a T or F? If not, continue. So then the line right below it would not run if the continue occurs. But if it doesn't occur, then we know that word begins with a T or an F, and we go ahead and append that to the empty list B. And that answers that question. The answer to question 2, breaking out. We can take a look that we made it an infinite loop by saying while true, and because that's a hard-coded true, it will never be false, so that's an infinite loop. Then we catch the user input, we test the user input to see if it's equal to Q, and if it is, we break out. If not, we just continue running calculations. All right, and the answer to question 3, 1, 3, 5, 7, 9 prints out. If line 5 is removed, nothing prints out, and that is because the I would only be equal to 0, it would never be incremented. And then when I is equal to 0, we break out. Okay. Section 7, tuples and lists. Question 1. You have a list of items in a program that will never change or be updated. Should you use a tuple or a list? Why? Question 2, tuples. How many data objects are created in the above code? What prints out? Okay. And then finally, lists. How many data objects are created, what prints out, and why? All right, so no coding here, just need to understand what's going on. So take a minute to look at those, see if you can answer it. Pause the video if you need to, because we are going over the answers in 3, 2, 1. Here we go. Use a tuple. This is the answer to question 1. Use a tuple. Tuples are immutable and more efficient for lists that will not change. Okay. And then the answer to question 2 is 3 data objects are created. They're created on lines 1, 3, and 4 respectively. 4 C's print out at the end. So the trick here would be, if you didn't understand immutable, immutable, and how that works, you might think that line 2 creates a data object, but it does not. We have 2 variables that point to the same data object in that instance. Okay. Lists. 1 data object is created. Z prints out. The list is mutable. When B was changed, A incurred the same change, as they are 2 variables pointing to the same data object. Okay, so in this example, we're working with lists. Lists are mutable. On line 2, when we put B equal to A, we have 2 variables that point to the same data object. And when we change the B value of element 1, which is B0, to Z, A also has that change because, again, A is a variable pointing to the same data object that B is pointing to. Okay. That answers that. Let's go on to the next section. Section 8. Dictionaries and sets. Shallow copy versus deep copy. When can you use a shallow copy on a dictionary? When should you use a deep copy? So we might not have covered this in great detail, but there's a lot of concepts in programming that will be new as you go over them, and it's almost impossible to cover every scenario in these programming courses. But a good strategy is to go to Google and Google the terms to find out the data that you need. For example, we could go to Google and say shallow copy Python, deep copy Python dictionary, and we'd probably get a very in-depth answer on how to answer these questions. And at this level, with just the simple data, the answer is relatively simple, so you should be able to find it and answer it. And then question 2, copies. What prints out? Why? What is the proper way to implement this concept? Okay, again, this is a reference to the first question because we're talking about copies of dictionaries. So if you find out if you efficiently and understand the answer to question 1, you should be able to answer question 2 as well. And then question 3, sets. How do sets differ from dictionaries? What are a few use cases? Okay, so take a moment, see if you can answer those. Pause the video if you need to, because we're going to go over the answers in 3, 2, 1. All right, the answer to question 1. You can use a shallow copy when values are immutable data types. You should use a deep copy when the values are immutable. And again, this has to do with variables referencing the same or different data objects. So immutable types would be integers, strings, or floats, and so on. And immutables would be lists. And the reason you want to be careful when you're working with copies on that level is because you don't want to accidentally change a value for a variable that affects another or affects the same data object when you don't expect it, because that usually ends up creating bugs. And then the answer to question 2, copies. Z prints out. This occurs because the list is mutable and a shallow copy was used. This caused the list variable to reference the same data object. Okay, so that makes sense. And that's the difference between shallow copies and deep copies. If we had used a deep copy in that example, it would have caused A to print out because they would have all had their own effective copy, which was a real legitimate copy, and was different data objects. And would have, so when we changed B, we wouldn't have changed to A too. And then sets. Sets are like dictionaries without keys. Sets are good to use for various comparisons between different sets. For example, when values exist in both sets or when values exist in one set but not the other. So sets are a good data structure to use when you want to compare different sets, there's that word again, right, of data to see if they share data, they don't share data, and so on. Okay, so let's go on to section 9. Functions. Question 1, what are functions? Why use functions? Okay. Question 2, create a function that accepts 2 numbers as parameters. The function returns a dictionary of 2 sets. The first set is the even number between the 2 parameters. The second set is the odd numbers between the 2 parameters. Okay, so we're going to create a function that accepts 2 numbers as arguments, and we're going to create 2 sets of numbers between those arguments, the even numbers and the odd numbers, and then we are going to return those 2 sets within a dictionary. All right, there we go. And then question 3, scope. What is the scope of variables created in a function? Why is this a good thing? All right, go ahead and pause the video if you need to. Take a second to answer those, or a minute if you need to. We are going to answer the questions in 3, 2, 1, let's go. All right, functions are small blocks of code that do something specific. Sometimes described as small programs within your main program, they provide abstraction and promote the dry principle, which is don't repeat yourself. A lot of times when we write a function, we're writing a block of code that's going to be used throughout our program, and we don't want to have to rewrite that block of code every time we want to use it in that program. All right, and then the answer to question 2. This is the answer to that question. So we can look at the code to see what's going on. We have a function named answer, accepting 2 integers as parameters. We have an even and odd set, and then we go through a range of number 1 to number 2, and then we use the modulus operator to test if it's even or odd, and then we assign it to the proper set depending on that outcome. And then of course at the very end there, we return a dictionary with even and odd numbers. All right, sweet. So you don't have to get the exact same answer as long as you get the same result. And then scope. Variables defined within a function are only visible within the function. This is often called local scope. This is good because too many global variables promote spaghetti code. Local scopes help keep concepts confined into independent smaller boxes. So when we create that function, we're creating a small box of logic, and everything that's required for that box of logic to work is in that box of logic. If everything was global scoped, programmers might accidentally or be compelled to use variables from function A, B, and C, and then they're all connecting to each other in weird and strange ways. That worked at the time when the programmer was making the code, but then when you go back to edit the code, it's just very error prone to have to deal with a lot of global variables. And local scopes, such as variables only being visible within that, that function definition, is a good thing to have, even though on occasion it might do something that's kind of annoying, but it's a good thing. All right, let's go on to section 10. Class objects, attributes and methods. What are class attributes? What are class methods? What does the init method do for you? All right, and then creating a class. Create a person class. Provide a first name and last name attribute. Create a get name class method that asks the user to input a name. So we're going to use that Python input function that comes with Python in the format of first name space last name. So that space is going to be important. We're going to want to use that split method to get the first name and the last name. Invoke the get method in the init method. Okay, so that the init method is basically the constructor. So when we create this class, we want that function to immediately fire and get the name of that person class. Okay, and then test your class. All right, question 3, inheritance. Create an employee class that inherits from the previous person class. Add 2 class attributes, position and salary. Add a class method called impData that asks the user to input the salary and position. Call this method in the employee init method. Also, we will need to call the super.init method as well. So when we create a inherited init method, like we create another class, we inherit from one class which has its own init method, and we create our own init method in that new class, we have to call the parent init method to make sure that it runs. Otherwise, it just runs the one we created. All right, and test your class. So take a minute to answer that, code some stuff up. We're going to take a look at the answers in 3, 2, 1, and of course you could have paused the video if you need to, but if you didn't, let's go ahead and take a look at those answers. Class object answers. All right, attributes and methods. Class attributes are variables that belong to the class definition. Okay, class methods are functions that belong to the class definition. Okay, so there's a distinction right there, right? What's the distinction between methods and functions? Functions are often these free floating things that we call functions, those boxes of logic that do something specific, where a method probably belongs to a class. It's part of a class definition, but at the end of the day, it's also just a function. And then the init method is a special method that automatically runs when the class object is instantiated. Now that would be called a constructor in some other languages. And then let's take a look at the answers. Creating a class, answers shown above. Okay, so we have a class person. We have that init method where we are establishing those variables, the first name, the last name, the get name. Oh, the get name is a method, a class method. And of course, that self keyword is very important in the class definition. We have to use that to reference its self. Then we can see the definition of get name method. The result is equal to the input of enter a name, and then the first name and last name is equal to the splitting of that result. All right, and then on line 12, we create an instance of it. So if we ran that program, we would get prompted to enter a name. Okay, inheritance. The answer shown above. We have a class employee that inherits from a person, and that makes sense because an employee is typically a person. Of course, with all that automation talk, maybe that changes in the future, but right now an employee is a person. So we inherit all that previous code that was defined in that person. We have our own init function where we add a position and a salary. Okay, because that's usually related to an employee. They have a position, they have a salary. Then we also call that super init function. And the reason we have to do that is so that that one in the person class also runs, because that's where we're getting the name. We don't have to retype all that code. We're just going to use the one that exists. And then we have the self.impData method where we get the user to input a position and also input a salary. Okay, and that answers that, and that finishes sections 2 through 10. So I hope you enjoyed this review, and in the next lesson we're going to continue on to section 11 and move on through programming with Python. Hope you enjoyed this lesson. I hope to see you in the next, and have a great day.